Okay, so this is problem 1918b on Codeforces. This is, I think, a 800 rated question, whatever. So give the problem a read from here to here. It's not very complicated, but I'm just here assuming that you read the editorial and you're still stuck. Fine. Okay, whatever. So what we do in this question is, I'll just take an example. Let's take this example, say 31425, and I don't know, 14235, something like this. So what the editorial is missing is that you must swap adjacent elements only. Since any configuration can be reached by swapping adjacent elements only, uh, why don't you restrict yourself to swapping adjacent elements only? Now, since you can reach any configuration, let's uh, restrict our swaps to adjacent. Why? Because if you take any two non-adjacent elements and swap them, you will be increasing and decreasing inversions that will be very hard to track, and we don't want that. We want something that's easy to track and that'll also do our job, right? Now that you're restricted to swapping adjacent element only, now just like the editorial, the two indices can have one inversion, uh, they can have two inversions or zero inversions. Let's just see an example. These two indices are an example of one inversion, because 1 is before 4, that is not an inversion. 4 is before 2, so that's one inversion. So that's one inversion, and swapping these two will keep the total number of inversions unchanged, because this will become an inversion and this will fix itself. So just imagine the total number of inversions here in this scenario is, say, like x something, okay? Swapping these two elements will only change it by one. We will not affect the relation of these two elements with any other elements in the array. So that's very easy to analyze. And from here, we can get some idea looking at the test cases. So one of the test cases is 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. So this is somewhat of a hint, right? Because in fact, the answer comes when one of the arrays is sorted. Let's keep that aside for now. So what do we know till now? We know that swapping these two adjacent elements will give us a definite change, and we can track it quite easily. Well and good. Now what do we do now? We will sort one of the arrays. Why are we sorting one of the arrays? Because that will make the inversions of any two indices at most one. At most one. And at most one is actually good for us, because we cannot do anything about one inversion. But if there's zero inversions, we can take it to two inversions, but that's bad. We don't want to do that. And if we have any two indices with two inversions, we want that to go to 0. Now if one of them is sorted, every index has every two adjacent index has at most one inversion. So what does this mean? If it has at most one inversion, it means I'm not in the bad case. And what's the bad case? The bad case is the two inversion case, right? So that is obviously the best case scenario, and that is the answer. So the answer is we sort one of the arrays, and that's the full context.